One. Greetings, everyone. This is the Cybersecurity Batch 6 for doing a presentation on disjoint set and self-organizing list. And this is presented by Anirudh Srinivasan and Vikrant myself. So further on, it will be to Anirudh.
Yeah. So these are our team members. So for the developers, we have these people, testers and business analysts. So these are our table of contents. So beginning with the introduction, disjoint set will be covered by Vikram.
Yes. So mathematically, a disjoint set is two different sets which has no common elements in them. So in data structure terms, disjoint set is actually a bit of an extension from graph data structure, wherein the link between any two elements are represented by an edge, either unidirectional or bidirectional, right? And one thing to keep in mind is that in disjoint set, no two element, a set which has non-overlapping elements is called a disjoint set. So we'll need to keep that in mind. And some of the major functions which we'll do is add new element, merge two sets, and also check if any two element presents in the is present in the same set or not. Over to Anirudh for self-organizing list.
Okay, so a self-organizing list is basically similar to just a regular list, but this list contains something called dynamic reordering. So basically, dynamic reordering is basically a list that organizes or sorts itself based on access patterns. So for a self-organizing list in specific, it organizes itself based on what element was most frequently accessed and what element is most recently accessed. So this highly improves efficiency. In certain programs, we might need to access an element repeatedly, and so increasing the access time of those elements will greatly improve our efficiency. And it uses something known as move to front, transpose, or frequency count, and it's beneficial in practice. So these are our implementations. So for self-organizing list, we have insertion, which basically checks if the list is full or not, and then inserts an element otherwise. Deletion, which basically traverses the list up to the given position and deletes the element in that position. Search, it uses a for loop to check if an entered value exists in a list and outputs true or false. This is basically known as the accessing point. Is empty, checks if the list is empty, is full, checks if the list is full, and get size returns the size of the list. Moving on to the implementation of disjoint set will be covered by Vikrant.
Yes, the functions in disjoint set are comparatively lesser. So make set literally creates a new set, a single element set, and it initializes the parent of the element as the element itself and the rank of each element to 0. Union set gets two elements of two different sets and merges them based on how their ranks go on. The find function literally finds the ultimate parent given of a given element in a given set. GetRank and getParent displays the rank and parent of the particular element which is passed as an argument. Now moving on to the real life implementations. So Anirudh here will explain the code step by step for the self-organizing list.
Okay, so here we have the code for self-organizing list. So first up, we start by declaring what the max size of the list is, which is basically S. The max value S can take is 100. And we also declare the list in which the elements are present and the count values of each of those elements. So first size is 0. So for the first function is empty, we check if the list is empty, and if so, return 0. And is full basically checks if the list is full and returns the size, which is the max size that S can take, which is 100. Void make empty basically makes the list empty. That is, removes all the elements from the list. Get S function basically returns the current position that we are traversing inside the list. Void insert of int val. So basically inserts the integer value or val inside the list. If the list is full, it returns an error. Else, it basically inserts the value inside the index, and it increases the size of the list. So at first, the size is 0. If one element is inserted, then size is increased to 1. Then void remove of in position. So for it basically removes an element in a given position. First, it checks if the position is within the range of the list. If not, it returns an error saying invalid position. And if yes, it is within the range, then it removes the element, and then it basically reduces the position of the next element to what the previous element used to be. And it also changes the count. And the size of the list is reduced again. So search. So search is basically the access part of this list. So basically, once given an integer, it traverses through the list and checks if the element is present, and if so, it returns true. And if this is true, it increases the count of that element. So the count of the element in that position, count of pos. So basically, it increases the count. So for example, if a list contains 1, 2, 3, 4, and 5, and if you're accessing 3, then the count of 3 increases. So count of 3 will be by default 0. If it is accessed, it will become 1. And the element 3 will move to the beginning of the list. And then print list basically prints the list, obviously. So here we have the main function. So here we are inserting 10, 20, 30, and 40 into the list, and we're printing the list. So yeah, as you can see, 10, 20, 30, and 40, and the count of all of them is by default 0. Next, we are searching for 20 and we're searching for 10 and we're printing the list again. Since we search for 20 and 10, both 20 and 10 will move to the beginning of the list and their count will be increased to 1 since we have accessed them once. So 20 count 1, 10 count 1, and the rest will remain the same with count 0. And so now to explain disjoint set, we have Vikrant.
Yes. Disjoint set. It starts by where we define the disjoint set based on structures and its corresponding functions inside the structure itself. So first we initialize parent and rank to the maximum size. Here it's 100. And void of next set of any given element literally creates a new disjoint set of single element wherein the element's parent is the element itself and the rank of each and every element is initialized to 0. Now, int of find of index, what it does is for each and every element in each and every set, it finds who's the ultimate parent is. For those who don't understand, the ultimate parent is the element in a particular set whose parent is themselves. So we are finding the ultimate parent through this function. Void of union sets gets two elements in as arguments and checks if the ultimate parent of those two elements are same. Because if they are, they belong to the same set and thereby there's no need to merge. But if they do not, they compare the rank of these two elements and correspondingly it creates a set where the element which has higher rank is made the parent and the rank of it is incremented to. And get rank and get parent displays the rank and parent value of the given element passed as an argument. Now as an example, we have here make set of 1, 2, 3, and 4. This creates four different disjoint sets initially, and rank of every single element is 0. Now, union sets of 1, comma 2 creates an edge between 1 and 2, wherein the rank of 1 is increased and the parent of 2 is 1. 3 and 4, the rank of 3 is increased and parent of 4 is 3. And union sets of 1 and 4, the rank of 1 is further increased and thereby 1 becomes the ultimate parent of all the elements together. So this is an simple example of how the disjoint set works. Now moving on to the applications, we are going to be focused on the applications of disjoint sets. So as you can see in the presentation, can you change to the next slide? Yes, thank you. So disjoint sets. The thing with disjoint sets is that the one of the most important application is that job sequencing. Many a times, jobs in any particular app, jobs are sorted based on their salary, and this has been possible due to disjoint set. Can you move to the previous slide, Anirudh? Yes. Here you can see two other applications wherein the graph representation, as I discussed earlier, is this disjoint set is an extension of graph representation wherein each link is represented as an edge. And cycle detection, as I said, if any two elements have the same ultimate parent, then they belong to the same set, thereby it creates a cycle. And this is exactly what is represented over here. Moving on, Anirudh, yes.
Yeah. So these are the infographics of our project. So these are basically our timelines, what each task took, how much time each task took. And this are Gantt chart, basically providing you a graphical representation of how long everything took. And these are our resources. So for disjoint set, we used Geeks for Geeks and Top Coder. And for self-organizing list, we use Geeks for Geeks, Wikipedia, and we took references from the book Cloud AI and Data Structures and Algorithms by Mark Allen Weiss.
A point to be noted is that we didn't take the code entirely, but then we get inspired from Geeks for Geeks and Top Coder because they had better time efficiency than the other codes which we refer to. And thus we implemented the better time efficient code in our particular project. Thank you.
Thank you.